quick overview and introduction to the course, right? So the slides here are slides from a couple of years ago where we taught calculus from scratch to confidence in 5 hours. And that's about all the time that you need. Now, what do I want to look at? I want to look at specifically the understanding of the need for calculus. What does calculus do for us? How does calculus assist us? How does calculus, where is it useful, right? Then we will look at sketching cubic graphs, and this is where we have a specific application of the principles of calculus, right? Understanding limits, which we've already had an introduction to by now, looking specifically at the derivative, finding equation of the tangents, and then the rest of it is what I would call standard sketching stuffs. So in other words, whatever applies to sketching normal graphs beyond tangents, derivatives, and limits all apply to calculus as well. Okay. And then thereafter we'll be looking at practical applications of calculus. Okay. Now, this is something I just want to mention to you, fundamental method to solving problems. You need to know what you're being asked, and that's why, as a general rule for every section in both calculus, physics, mathematics, I will insist that you read the question. Look at what you know, and then you take your known information to try and find a connection between what you know with that which you seek. And that's going to become important for us. Okay. This third point, what I'm trying to say is when we build new knowledge, you need to relate it to old knowledge. So seeing that you learned limits yesterday, I'm going to use the concept of a limit. Seeing that you know about gradients, I'm going to use those concepts as well. And we're going to see how to manipulate that so that it fits with the calculus connection, right? Okay. Now, this is the first 3 tips I want to look at with you guys. Lead with the end in mind. You guys need to embrace the challenge. We're going to specifically be looking at sketching cubic graphs as an application of calculus. So in other words, everything that you are learning now is a build-up to being able to draw a cubic graph. Okay? That involves both pre-calculus work as well as the calculus work itself. You need to make a summary sheet or an explanation sheet. This is your reference sheet. You'll notice that you need to make one when it comes to sequences. You need to make one when it comes to trigonometry. You also need to make one when it comes to calculus. You use that sheet as your core reference for when you go and you study for your examination. And then finally, this is a very mechanical area. If you want to get full marks in calculus, 100%, which is very, 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 very doable, you need to practice. Okay, got it? Okay, now people, what is calculus? Can anybody tell me what is calculus?
The mathematics of change.
That's what calculus is. It is the mathematics of change. And up until this point, you've been dealing with very, very boring mathematics. You've been dealing with regular math problems, right? Do you see that over there? That's a regular math problem. This here is a calculus problem, okay? Why is this a calculus problem and this is what I would call regular math? Can anyone tell me?
Because regular math is straightforward.
It's straightforward, it's easy, as you can see here. What type of curve is this that this guy is moving on? He's moving on a linear curve or a straight line. And whereas this thing over here is a curve, right? It's like a wave, right? So this here is not so obvious, it's not so simple. Okay, because here as he moves, if he expends the same effort, right, he'll be able to move the same displacement each time. In other words, if he applies the same force to that, then in the same time unit, he'll keep moving the same amount. But here, if he keeps the same force, it's going to alternate as to how much he moves on that curve, is it not?
Yes.
Right? Because where it's steeper, he needs to put in more effort, right? Where it becomes more of a plateau, he needs to expend less effort. Okay, so that gives you a bit of an introduction, a bit of idea of calculus. Okay, let me just see what's on the next page quickly. Okay, right. So this is already the answer as to what that involves. But before we do that, I'm going to give you a bit of a further explanation of some stuff. Okay, so we've already defined calculus as what? The mathematics of change, right? And because it's the mathematics of change, it's also the mathematics of life. Because most of life doesn't look like a regular math problem. If you take this curve, what happens over here? We already said everything is linear. If you look at this, what's happening? That's more like life, right? Because this is how you guys think your mathematics marks look. You know, as time goes on, I put in some effort, everything just works like that. But it doesn't. Sometimes it goes up, goes down, moves around, and eventually, you know, because there's a lot of factors involved. Now, what calculus is going to do is, I'm going to introduce to you two concepts now. The one is called the average gradient. Okay? And we'll talk about that.